Hey, hey, welcome, welcome. And today, well, I got my French national team soccer scarf on me. Allez, France! Okay, so today here for apes, we're going to be in chapter 18, section 2, looking at pollutants. Now, there's two basic kinds of pollutants. We can talk about primary and then secondary pollutants. We can talk about smog as well. So I'm actually going to break this into two parts. I'm going to talk about primary and secondary pollutants, and then after that, I'll talk about the smog. Okay, that's going to be two separate videos. So those are the objectives for today. Okay. So the reality is air pollution, there is no such thing as the ultimately clean air. It's not happening. You get air pollution from natural and human sources. Okay. When we look at air pollution, we're looking at chemicals that are in the atmosphere and that they're in high enough concentrations that they can affect humans, plants, animals, freshmen. Okay. So that's the basic definition of pollution. You've got chemicals in the atmosphere, and it's high enough concentrations that it impacts humans, plants, animals, and freshmen. Okay, well, okay, but what about the sources? Interestingly enough, with all the global climate change and burning fossil fuels, people, most of it comes from natural sources, like dust particles and organic chemicals that come from decaying plants, forest fires, volcanic ashes, and see spray. Okay, I'm not going to spray into the camera lens. Are you kidding me? Okay, I am not going to do that. All righty. So here we go. So that's really it. Sources, most of it's natural. There are some that are human sources, okay? But natural include things, again, like dust particles, organic chemicals that we get from decaying plants, forest fires, volcanic ashes, and volcanic ashes and sea spray. Okay, the button's not working. Oh, lame, lame, lame. Okay, let's move on. Okay, what other sources? Well, we talk about humans helping as well. Burning the fossil fuels like coal, gas, natural gas. We also burn wood, but it's kind of an important thing we need to do because it helped civilization develop. It helped, you know, people to improve their lives, stay warm, cook food, lifespan gets a little longer, helps develop medicine, things like that. So lifespan goes onward. It's increased as a result of these energy sources. But yes, they do put pollution into the atmosphere. Now, what about the sources? Well, they're stationary and mobile. So stationary, again, those are sources that they don't move, like power plants and factories. That's pretty obvious. They can't just pick up and walk away, right? On the other hand, mobile, we have motor vehicles. And here in the SoCal, we got a lot of mobile sources, okay? I put AOC on there just for people to think about it. Let's get into primary pollutants here. So, really, when we look at primary pollutants, those are emitted directly to the troposphere in harmful form. Wait, what do you mean by primary? Well, this is what's going from the source into the air and it's in a harmful form. Now, keep in mind, a little bit is not the end of the world. The idea is that if you have a high enough concentration, that can impact humans, plants, animals, and freshmen. Okay? So when we talk about the troposphere, remember in that last video, we talked about the layers of the atmosphere. If this is the ground level here you have these layers of atmosphere. The troposphere is right here. That is the part of the atmosphere that we are in, and we're sucking in air, and you guys brag about how cool you are to your friends over the internet. Okay? So things like, for primary pollutants, you guys really need to know this for the exam. Things like soot. Now, what is soot? When you burn wood or you burn paper, when you're burning something and you're getting the fire crackle, crackle, you get smoke, right? But you also get little black particles that they will settle somewhere. That is the soot, okay? There's soot, then we have carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen dioxide, and nitrous oxide or nitrogen monoxide. I'm sorry, it's not nitrous oxide, it's nitrogen monoxide, and most hydrocarbons. Now, remember about the hydrocarbons, this is those molecules that have C and H in them. They are the hydrocarbons. They have hydrogen, they have carbon in varying numbers. Okay. So when we look at carbon monoxide, that's CO, and this is how we get it. 2 carbon plus O2 gets 2 CO. That is the basic way we get our carbon monoxide. Sources. This page is so important. I can't emphasize it enough. Cigarettes and car exhaust. Okay? Cigarettes and car exhaust. Now, we also have nitrogen dioxide. Now, that can be changed, converted to HNO3. That would be nitric acid or acid rain. Don't you know that it hurts so much? Acid rain. When those green trees start turning brown. Acid rain. Okay. Sources. Fossil fuels and industrial plants. Remember, when you're burning fossil fuels, you're putting out a number of pollutants directly into the atmosphere, and we're interested in the heat that they generate, and we can power machines, things like that, okay? And this is an example of acid rain formation. This is a handy little diagram for that. So SO2 and NOx. Okay. What's up with the NOx? NOx can be NO2, NO3, it could be NO that goes up in the air and it mixes with the water. And then what happens is when it comes down in the form of acid rain. And we'll talk a little bit more about that in the chapter. So, carbon monoxide and nitrogen dioxide. Sulfur dioxide. Oof. All right, primary pollutants. Again, we say it's emitted directly to the troposphere in harmful form. I'm just repeating this again for people to remember. So sulfur dioxide's a nasty one because you have sulfur plus O2 gets you SO2. All right. The sources, again, coal burning in power plants and industry. Coal, the reason why a lot of environmentalists don't like coal, that's because it puts out SO2, which can become part of acid rain. It also puts out mercury. Yep, and some radioactive isotopes. It's very small levels, though. So what you're seeing here, guys, these two pictures, this is the result of acid rain. I told you that the green trees will go brown. Acid rain. Look at the stonework, it's now down. Acid rain. Okay, you guys remember in chemistry that if you have a high enough concentration of acid, that it can go and start breaking down things. It can start dissolving things. And that's what you're seeing with the trees here, and that's what you're seeing with the stonework here. It hits and it just slowly dissolves, okay? Because a lot of the statuary and the fancy rock work that you're seeing there, it's marble. And marble is likely to be affected by acid rain. That's why you've got the damage there. Now, in Southern California, we do not have acid rain. We have acid fog instead. We do experience that in the San Bernardino Mountains. And again, same reasons. It's pollutants that go into the air, mixes with the water. And when you have the early morning fog going through the San Bernardino Mountains, it does affect the trees. Okay, but it's not to the point what you're seeing here, and it's not to the point of what you're seeing here. This is just outright acid rain, period. Okay. So, what other primary pollutants are we dealing with here? Well, we've got suspended particulate matter, SPM, SPM, okay? Burning coal and diesel, unpaved roads, agriculture, and construction. Now, what do we mean by suspended particulate matter? What's a particulate? Well, it's a tiny little thing. You could look at like dust, for example. You could argue that is a particulate. Now, if you don't know this, the dust that when you go dust your table, dust the bookshelves, if you ever take a look at, if you take a close look at dust, a lot of it is dead skin cells from people and animals. Bet you didn't know that. Little knowledge goes a long ways. Okay. So if that's suspended particulate matter, especially from burning coal and diesel, unpaved roads. So roads that are dirt roads, trucks, cars, people, horses, freshmen, they walk along it. They kick up this suspended particulate matter and it goes up into the air. Okay. That's part of nature. Okay. There's also agriculture, construction. They also generate this suspended particulate matter. Okay, then we get into ozone. O3. Not Frozone of the Incredibles and Incredibles 2, which I thought the first one was better. But it is ozone, O3. Now, the thing about it is you have chemical reactions with volatile organic compounds, VOCs. What do we mean by volatile? For people, if we say this person is volatile, we mean that they get upset very easily. They may get mad very easily. What do you mean? That would be volatile. When we talk about volatile for organic compounds, volatile means it's going to evaporate very quickly into the air. That's the idea behind volatile. It can easily evaporate, go from a liquid to a gas very easily. Okay? And VOCs, that pretty much comes from decay of plant material. So, ozone, chemical reactions with the VOCs, volatile organic compounds, and nitrogen oxides. Okay? Now, there is good ozone in stratosphere. Okay? That filters out the ultraviolet radiation. It cuts down on us getting skin cancer. That's a benefit, you know. God thought about that and he put the ozone in there because if we didn't have the ozone, we'd be dead. I'm just saying that life on Earth just would not happen. And one of my favorite ecological horror movies called Day of the Animals is actually on Amazon Prime, filmed in 1977, PG rated. The basic story is the ozone is thinning so much, the animals at 5,000 feet and above are going crazy and attacking people. It's hilarious. It's a funny movie in that respect. Okay. Now, we have not seen that happen in real life, but in the 1970s, they loved to do what I call the ecological horror movies. Okay. And I think among my favorite would be The Day of the Animals. Okay. So, chemical reactions with volatile organic compounds and nitrogen oxides. Good ozone in the stratosphere filters out UV rays, like I just said. Bad ozone. Ooh, bad ozone. Well, what do you mean, bad ozone? Well, that's the pollution when it is in the troposphere. Okay. So there is ozone that's up there in the stratosphere, it's a layer. And then there is the ozone that is trapped in the same area where we are breathing in. And that's not too good for us. Okay. And we'll talk a little bit more about that. I'm going to take off the scarf. You know. Whew. Okay. I'm going to make the best of this, okay? Because I am talking to the future and you are listening to the past. Think on that. So, with that, we talked about primary pollutants. Let's see. And we have another one. We've got lead. Lead is another one. You find that in paint. Nowadays, the paint that is made, and it's been like this for quite some time, you don't have lead in paint anymore. Same thing for leaded gasoline. Old school paint, old school gasoline had lead in it, and that was definitely a primary pollutant that it would go out into the air directly in a harmful form. We do have it in lead making. Storage batteries, your car batteries have lead in them. Again, this is being phased out in developed countries. It's kind of an important thing. Okay, so if you look at the diagram there off to the right, you're going to see the effects of lead poisoning. It's not instant. Okay, there's a number of things that go in there as far as what lead poisoning is. Okay. So again, volatile organic compounds, okay, VOCs. Most are what they're called isoprenes, terpenes, and methanes. So I gave you the formulas for isoprene, terpene, and the methane. I could not do the subscript thing on PowerPoint. There is a limit to what I can do. So you need to know the VOCs, isoprenes, terpenes, and methane, given off by leaves of plants, okay? 33% of the methane given off by plants, wetlands, and termites. That's natural. It's natural. It's not that we can go and control it. 67% are human sources, like landfills, okay? Trash that we bury and cover it up. Oil and natural gas wells. Yeah. And belching cows. Cows that burp. Natural process. Now, notice they said put in human sources. Well, that's because we have so many cows. We raise them for things like, I don't know, milk, cheese, butter, meat. Yeah. Yeah. Primary pollutants, we continue that. So 67% of the human sources there, as I mentioned, landfills and oil and natural gas wells and belching cows. So you can see the landfill picture on the right. Look at the left for the cows. 90 to 95% of the CO2 is coming from the cows belching. Now remember, a cow has 7 stomachs. If you look at the other end, the CO2, that's between 5 to 10%. Okay, just the thought. Okay, I think I am going to stop here and just go with primary pollutants. I think we're done here for that. And then I'm going to break it down into a further part where I'm going to have you guys cover secondary. Well, actually, you know what? Secondary is not that far. It's only one slide. Sorry, guys. Let's go one more. Now, secondary pollutants, really what those are, they react with the primary pollutants to form another pollutant. Okay. So things like PAN, where peroxyacyl nitrates, that's where you get the PAN from. NO3 minus, SO42 minus, salts, and ozone. Those are examples of secondary pollutants, ladies and gentlemen. Okay. And with that, we have ended up covering primary and secondary pollutants today. You know that secondary pollutants are the result of primary pollutants that go directly into the atmosphere in harmful form, and it's in enough amounts, a high concentration of it. Okay, we've looked at primary pollutants, for example, like volatile organic chemicals. Okay, we've looked at that. We have looked at lead as a primary pollutant. We've looked at ozone as a primary pollutant. We have looked at suspended particulate matter as a primary pollutant. Okay, we have also looked at other things like sulfur dioxide as another primary pollutant, carbon monoxide, nitrogen dioxide. All those are primary pollutants. Okay, we talked about the idea of air pollution on this in the past. Okay, and we also looked at air pollution from natural and human sources, I should say. And then that leads us here to the end. So I'm going to stop here and catch you on the flip side.